So looking at the kernel density estimation plot, this is a good plot. It's a good plot when you want to really just inspect the outline of the data set. So what it has, kernel density estimation is using actually a little bit more complex machine learning mathematics to essentially smooth. It's kind of like the moving average of a time series data set. It's essentially smoothing out and trying to find out the space in between the data points and plot something along in that sense. You can change the bandwidth in this, and so that'll allow how much is it assuming there is detail, or how much is it assuming the in between parts between the data. I usually like to turn it down a little bit so you don't get that full completely smooth. You get a little bit of the detail of the data. You can see here in this plot there's, you can turn it down too much and there's almost, it defeats the purpose. It's just kind of a mess and kind of just really too much noise again that you're dealing with. This works really well when you have a lot of categories and you want to use the hue argument in Seaborn to inspect the distributions by, or see how the categories are changed by the, or how the categories play into the distribution. Again, you have to be careful with how much detail you want to see, and kind of generalization is usually a good thing. Kind of like our image here, you can see this woman. That's a lot of detail. She might be beautiful, but it's hard to tell, behind all that detail. That's one of the things we have to be careful playing around with the detail of the KDE, the kernel density estimation plot. But it can be very powerful. It's because of its simplicity. It can be very powerful.